In this video, we will start a brand new series on Beginner's Guide to SDL2 in the G4 language. That's the fourth language, but I'm specifically going to be using the G4 version. So to follow along with this, first thing you'll need to do is go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in G4, and you're going to need to clone that repository. So let's do that. So I'm just copying the URL directly. And here I'm going to remove, I already have it on my system, so I'm going to remove it first. And I'll use git clone, there it is. Pull it down. And I'm using NVim, but you can use whatever you want to use, VS Code or kwrite, or not kwrite, Kate or whatever, gedit, something like that. So in here we have different folders. So we have all the assets that we need for this project, which are going to be fonts, images, music, and sounds. Those are all the assets we're going to be using. We also have the actual bindings for SDL2 for G4, and they're in the SDL2 folder. This is the bindings, and I'll talk about those in a minute. We have all the source code for all the different videos already in each one of these folders. So video 1, 2, 3, 4, those are going to be what we'll end up with at the end of each video for our source folder, or for the source code we're working with, and they're just a main.fs file in each one. And on the top level directory, we have what we're going to actually launch is the main FS right here. Okay, let me just show what we're actually building with the end of this project. So right here, I'll just make it a little bit bigger. So I'm going to mute the music and then just show you kind of what it's doing real quick. And to run this, I'm going to use G4 and then main FS. Okay, I'm going to mute the music.
SDL. Fourth.
I can change the color. I can move my character around by using the arrow keys or the ASWD. And then SDL is bouncing around itself and saying SDL as it does it. And then every time I press the space bar, I can change the color of the background, and it also says a G4, or it says 4th. And we also have a title up here for this, and we have a sprite that has already loaded. So I'm going to close this. So you can kind of see we have all the components that you would need to build a game. We have loading sprites, we have using making fonts, moving things around, checking collision with the edges of the screen, controlling things. We are also checking for keyboard inputs, for muting music or changing colors or closing it, and checking the events like a quit event and things like that. So these are kind of all the different components that you need to start making simple games. Now that I've showed you that, let's just talk a little bit about what's SDL2 and what's 4th. Now I'm assuming you already have a little bit of 4th knowledge first, so SDL2 is the simple direct media layer, and this is a C library that basically makes it possible to create 2D games with sound, creates the window, allows you to load images and text and everything else, move them around, get keyboard inputs, and it abstracts away a lot of the boilerplate that you would need to do with. So you can just go ahead and use this on different operating systems and different hardware. So this is the C library, but we have a binding to allow us to use the C library in 4th. So we have this C library that we're using. It's used in actually a lot of different places. If you use Pygame, Pygame 0, GoSu, it's obviously used in C, C++, Go uses it, Haskell uses it. You could use it in Rust, you can use it all over the place. So we're going to be using it in G4 specifically, and that is going to be, so this is going to be us interfacing with this C library that is SDL2. So if you don't know too much about 4th, there is great resources. You can go to 4th.com, starting 4th, and there is an online book that kind of you can learn all about 4th, and it's a really good place. It's a very simple, this is not a 4th video. I'm not explaining exactly how 4th works, but it's a stack-based language. It's interpreted, but it's also partially compiled. It's very small, very simple. It's quite a bit different than the other imperative languages, but it's still very, very easy to use. It's also quite fun to use, but it is different. But also it's very interesting if you're kind of working with lower level languages like C, and even lower than C. I think this is lower than C. You're going to be working much closer with managing your own memory, creating your own data structures, working with memory directly. And this is very much a step above using, say, assembly. So if you kind of like how assembly, you're really interested in assembly or lower level languages, definitely C, and then fourth, and then down to assembly or something like that. This is kind of a step up from assembly, but also in a way that's interpreted, but still very small, very easy to use, and quite fun. So this resource right here, if you haven't seen it, I can make it a little bit bigger. This forth.com, this is a great place to check out. You probably, if you've already been checking out Forth, you've probably been here before. And there's also, I think this is found in many different places, but since I'm using gforth, there is the manual for gforth is a good place as well to get resources. Yeah. So I actually started out with Forth by watching a couple videos that were showing how to, a little bit about Forth, and then claiming they can make videos with video games with Forth, but then not actually showing how to do that, and then finding out that you couldn't actually do it with what they were saying. So you'll find these videos on YouTube. It's unfortunate that you can't actually make games as the person kind of showed that you could. And the problem is the bindings were missing. And this led me down a rabbit hole where I ended up making my own bindings. So I didn't create these all from scratch myself. I actually went looking for quite some time and ended up on other people's projects that had almost working bindings but weren't finished yet. So the bindings I have basically are from some of those projects, and then I put a lot of time into actually augmenting them and making them work. So I'm not going to explain too much about the bindings right now, but what I want to say is that these basically mirror the SDL2 header files. So if you can do it in SDL2, you can do it here with these bindings, basically. And this, I'm on a 64-bit system, so I haven't tested this on a 32-bit system, so I hope it works for people that are on 32-bit systems, but I'm not 100% sure because I'm on a 64-bit system. But a couple things I just want to discuss about it real quick before we jump into actually making something is that this works exactly the way that you would use this in C or C++, as in we're going to require the, where is it? Let me just show you real quick what I'm talking about. So up here, if you were in C, you would include, SDL2, SDL .h. So this is very much like this. So since this in this SDL2 folder here, those were actually where the bindings are. So you still need SDL2 on your system, and you still need the library and the header files that are the C library and the header files. You still definitely need those on your system. But these bindings, they actually compile and talk to those. So you would just require just the way that you would. And then if you want to use the image module, you just require that one. If you want to use TTF, if you want to use Mixer. So it's going to work exactly the same way. But there is a couple little changes that had to be made. So for one, Forth is not case sensitive. So there's a function to shut down SDL2 called SDL_quit. But there's also an enum that is SDL_quit, but all capitals. And that is a preprocessor macro or an enum. I'm not sure. It's an enum. So since those two are actually different in C, but in Forth they are equivalent because there's nothing checking whether it's a upper or lower case, then we have naming collisions. So on those items that had naming collisions that were enums, like SDL_quit, I just added another underscore and called them enums. So that happened, looks like 6 times. So all 6 of those times, I just added an underscore enum. So the one that you'll notice is the SDL quit. For checking the equality on an event, if a quit event happened, it'll be quit_enum now. And so that fixed up the problem with naming collisions. The other thing is whenever you call a function in SDL, it's almost always using a pointer to something. However, in SDL_TTF and maybe a couple other places, they're passing in color structs, but they're not passing in the pointer to the struct. They're actually passing in the struct itself. And this can't be done as far as I know from Forth. It may be able to be done, and I just don't know how to do it. But so what I did is I ended up creating wrapper functions that basically took in the pointer to the struct. That does work, and then dereference that pointer and handed it off to the C struct. So I made my own C wrapper function under the hood that does it for me, and you're going to call it the exact same way that you believe it always should be called. It's going to have the exact same names and everything, but we'll be passing in pointers to the struct, so it works for us. But everything else will look the exact same for you. So that's a slight different other if you were using it from C or C++. And there's no null in Forth, but it's just 0. So I just made a constant for null in the code that we're going to use. No big deal. So the other thing is dealing with strings. Forth uses a character array and a length. So it puts two things on the stacks. One is the character array and one is the length, so that it knows how long a string is. And C doesn't do this. C has a character array, but it's null terminated, as in the last character in the character array is a null character, is a 0, not the number or the letter 0, but a real perfect 0, which is called the null character. So to do this, to go from a Forth string to a string that I can send into C, is quite simple. I can just simply use this type of string in Forth that allows me to use an escape sequence. So S / and then double quotes is the word for creating a string with an escape sequence. So if I do that, and at the end of my string, I do a \0, that adds a null character to the end of my string. So that almost gets me to a C string, but now I still have the length of the string on the stack. So you can just drop that length, and now you have a C-style string. So that's easy enough to send in strings to Forth strings into C functions. But if you're receiving a string back from a C function, now we need the length of that string. So there is a word that I've set up down here in Forth, like things like functions are called words. So this is a word definition right here. And all this is going to do is it needs to be a C-style string that has a null terminator, but it's just going to continue down the whole length of the string until it finds the null terminator. And every time it goes another character, it's going to increment itself. And so it basically, when it hits the null character, it knows how long the string is, and it adds that onto the stack. So you end up with the address to the string array and the length, which is exactly what you need for a Forth style string. So here's the word here. It's called C string len. And what this is doing is it's taking the address to a character. That's what you would see in C or Forth. You would see an address to a character to the beginning of the array. And it's returning that same address to the character, but it's also returning a length. And so what it's doing here is this is a loop here, this begin, while, repeat. It's throwing 0 on the stack, and then it's got the address and a 0 now, and it duplicates both of them, it adds them together, and then it pulls that character out at that address. And if it's a 0, it's going to finish the while loop and it's done. So on the stack will still be 0. If it's not a 0, it's going to increment, and it's going to do the whole thing again. So it just keeps incrementing until it finds the 0, and then it's done. So all that does is turn a C-style string into something that Forth can use. So that is the conversion for taking a C string to a Forth string. I also talk about real quick down here, I want to move through this to get to some coding, but yeah. When you're pulling stuff out, so G-Forth on my system is 64-bit. I think on a 32-bit machine, it might be 32-bit, but on my machine, it's 64-bit, and that is a 2's complement style number. So it's called 2's complement. So what's important about that is the topmost bit is actually the sign bit, and that's the 64-bit. That would be the most significant bit, would be the sign bit. And on a 32-bit, it would be the 32, the most significant bit of the 32 would be a signed bit. So this is all fine. If I need to store something, I'm going from 64 down to 32. So I know whenever I use the store command, if I'm storing to a 32-bit, signed or unsigned, I need to use the L exclamation mark. That's a store command for a 32-bit. But if I fetch from it, I need to know if that signed bit, if it's a signed integer, I'm coming back into fourth out of C from, or out of a 32-bit, storage unit that was used for C or whatever. If I'm coming back out of that, if I'm pulling something from there, I need to know if that's assigned. If it's signed, if it's say a rectangle in C, those are 32-bit signed integers. If that's signed, I need to know that that top bit is signed, and I need to not use that as part of the number. I need to use it as the sign. So you need to use SL with the @ symbol to fetch from it. That's a signed 32-bit fetch. If you just use L, what happens here is down here I have this example here where I'm creating a rectangle in fourth, and then I'm assigning -1 to one of the members of that rectangle with the L. That is the 32-bit assignment. So I should have -1 in there. But now if I go to fetch from it, if I throw the address back on the stack and then I use the L @ symbol, that's a fetch. What it shows up on the stack is 4.3 billion. And that's because it didn't use the signed bit. It thought it was an unsigned number, and it gave me the big number. So if I do SL fetch, which is the signed 32-bit fetch, it will actually give me the correct -1 back. So we need to be careful about if we're doing signed and unsigned fetches. And also we need to be careful if we're storing, and we'll talk about this in code later, but we need to be careful about the size of things. We need to know what size it was in the C thing, especially if we're storing to something. It could overwrite other data, okay? So we'll talk about that a little bit when we get there, and we'll walk through it. And I'll show it a little bit. I just wanted to, this just talks about it again, about making sure the size of what you're sending and receiving. And this is just an example down here one last time of what it would look like in C. So in C, I would have this function. It would be returning a pointer to a window. So it's a window name pointer to an SDL window. And it's this SDL create window. And it's got one parameter here, which is a string, literal. And then it's got an X position, a Y position. If we scroll over, come on, let me scroll. Okay. It's got an X position, a Y position, a width, a height, and some, this 0 here is more flags. So it's just nothing on the more flags. And then the version for G4th would be very similar. We have the string, but we're adding a null terminator to it, and then we're dropping the unnecessary length off. So now we have just the address to the character array string. And then we can use the exact same SDL window pause centered. All those things that should be available for you in C or C++ when you're working with SDL2, those are also available to you because of my bindings. You have the same stuff available to you. So this SDL2 window pause centered, that's totally available to you. And so that is your X, that's your Y, your 800 and 600, we're just putting them in there right on the stack. So all these things are getting thrown on the stack. And the last thing is 0 for the flags. And then you call the word, which is the function in C, which is SDL create window. And that's going to consume all these things off the stack. And it's going to leave on the stack the address to the window that it created. And so here I'm using the value window. So it's a word window that I'm using. So I'm assigning the address to that window that's available. You can also do it as a variable. It would be slightly different, but you get the idea. Basically in C, we have the return is on the far left, then we have the function name, and then we have all the parameters. And in fourth, we have all the parameters on the stack. And then at the end of all the parameters, we have the word that we're calling. And then we are returning onto the stack what returned from the function or the word. So those are the equivalents. So that's a very long-winded, and I'm sorry about all that. But again, if you, in your own project, you want to use the SDL2 bindings, you would just need this folder right here. And that would be the only thing that you would need. And you do need to have SDL2 on your system. So let's just look at that real quick. So for me to use all this stuff, I need these things already installed. I need SDL2, I need SDL2 image, SDL2 TTF, and SDL2 mixer. These are not part of the bindings. These are the actual C libraries and header files. If your system has them separated into separate packages, like it might put the headers in a dev package or something like that, you will need those on your system as well. So those need to be on your system. And also, when you run this the first time, it ran really fast when I did this, right? When I ran, it runs really fast. But the thing is it actually is compiling it the first time I did it. So it compiles it into my local folder called G4th, and it's hidden. So if I do this rm rf G4th right here, it's going to remove, let me just show you what's in this folder. And there's actually libc in there. So it's actually compiling all the bindings that are in this SDL2 folder. It's compiling all of those. So if I were to, if you are ever changing these SDL2 around, you need to get rid of this folder and recompile it. Because if you make any changes here into SDL2, not your program, but you say, oh, the bindings aren't quite working, I want to try to change them. Maybe they're not working correctly on your system. If you ever make any changes to this SDL2, you want this recompiled. And the only way I know how to recompile it is just to delete it. So I'll just show you real quick. I'm going to remove this. Okay, and now if I run G4th in this, it's not going to run it again right away this time. It's got to recompile those. So it's going to take maybe 30 seconds or a minute, and it's going to recompile them. But just know that if you are making changes to SDL2, anything in here, anything in this folder, you're going to want to redo this. I had lots of headaches not understanding that the changes I was making, I wasn't seeing them because I didn't delete that folder. So it should be almost done. It should pop up the game when it's done. But once it's compiled, it stays compiled. So you don't need to, we won't be making any changes in that folder at all. So it's going to be fine for us the rest of the time. Okay, there it goes. Okay, so yeah, the first time you do it, the first time you clone this repository, you will have that minute or so time that it compiles, because it's actually compiling the bindings and you need to have SDL2 installed on your system and everything else. Okay, so all of that said, let's start making some programming. I'm going to delete this main.fs and we're going to start from the beginning. So I'm just removing this. No, I don't want to rename it. Okay, so that's gone. I'm just going to make a new one and I'm just calling it main.fs. Okay, so now we have this empty file. So the very first thing that we need to do is we need to require, just like if we were in C or C++ or Go or whatever, we need to bring in SDL2. And on this one, we're just opening a window. So we only need SDL2. We don't need anything else. And my SDL2 binding actually pulls in all the other stuff it needs behind it. So you just need to worry about requiring SDL2. Okay, so that will require SDL2. And now, like I said in my thing, C uses null a lot of the times. Now, you could just write 0 all over the place, but I'm just going to make a constant that is 0 is null to make it easier for me. And I'm going to be using these capital letters, either if, because it's like that because of SDL2, if it's a enumeration or a macro that's in SDL2 that is a constant, or if it's a fourth word. If it's a fourth word, I'm going to write it in capital letters. So that is that. I'm also going to make a string that is going to be the window title. So this is the way that we need. So normally in Forth, you could make a string like this. You could say like this here, and you need to put a space here because what it is S in the first double quotations is actually a word. The space needs to be there. And now I can put whatever I want. So if I put open window, this would be fine. What would happen is this would put two things on the stack. This would put the address and the length. And since we're going to be definitely going to be sending this into C, I don't want the address and the length, and I also want the null terminator. So to be able to use escape sequences, we use a slightly different fourth word, which is S / double parentheses. And that allows us to use escape sequences like \0. That will give us a null terminator. And then we can drop the let me just show you what I'm doing here. So if I was in G4, I can print what's on the stack by hitting period S, and there's nothing on the stack, it's 0. Okay, so if I make a string, let me just show you that we can't do it without putting a space. This is not going to work right here because I didn't put a space between the double quotations and the H. Okay, so if we do the same thing again, and now I do it, it says okay. So what happened? Well, on the stack is the address to the H basically, and the length. So if I do this, I have 2 items on the stack. That's what this is telling me. There's 2 items. The first one right here, this is an address, and this is a length. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're 11, we have 11 characters. So if I were to drop one, let's see here. Now we just have the address and we don't have the 11, okay? So I can't actually type this out anymore. If I were to use type, well, let me just put 11 back on the stack. Okay, I'm going to dupe this. I'm going to duplicate these 2 so I have 2 versions of them on the stack. Okay, now I'm going to use the word type, which is going to consume both of these, and it's going to print out hello world. There we go. Now on the stack, we just have 1 set of them. That's what the 2 dupe was. I knew I was going to consume those 2, so I made a duplicate of both of them. I'm just going to drop the 11 real quick. Or I'll just do an over. I just want the address up here. So I'll do an over. No, I'll do it. I'm going to +1. So I have a 12 there, yeah. Let's do a dump. Okay, so dump, what dump does here is it takes this 12 and this address, and it dumps everything from this address. It dumps 12 characters, which is hello world, and there just happened to be 00 at the end. Now it's showing me a period over here, but that's not what it is. It's not a period character. It's a null character. It's just kind of giving me a representation over here of what it is, but it's not truly a period. So now this period here has nothing to do with my string. This just happens to be what is in memory after my string. Now I can't guarantee what's in memory after my string. That memory actually doesn't even belong to me. It may be part of this program, so it's letting me show it, but actually it's something in this program that's not the string. It's maybe just more of my buffer that's already allocated to me for this program, but it's not part of the string. So it does look like it's null terminated, but that's just by luck. That could be anything there. We could have any kind of number there whatsoever. So what we really need is we need a null terminated string. So, and again, like I said, this is just happens to be luck that this is a null character here. That has nothing to do with the string that happened. So let's clear stack. Is that right? Yeah. So let's show that what I was talking about earlier, where we actually going to make sure there's a null character in here. So if I do this S and then I do a backslash, right, and then I go hello world, I'll put an explanation there. I think that's fine. And I'll put the 0. So I got a backslash 0. That should give me the null character. Okay. Now if I do this, okay, so we got 13 characters here. The reason why it's 13, not 12, because I put it, this time I put the exclamation mark up above. I didn't have it. That null character is actually counted in the string. So if I do a to dupe, just to duplicate them, and then a dump. Okay. Now this right here, this is actually part of my string. Before I had an 11 and I switched it to 12, so I was actually looking at one thing past my string. This is actually my string. This null character is part of my string right here, where it's being shown as a period, even though it's not a period. Okay, so you can see that a C string would be this right here, including the null character, not the 13. We needed the 13 there for the dump. The dump needs to know how many things to dump. So yeah, so basically for the C style strings, we just do this, and then we just drop the 13, and then we have a C style string. Hopefully that made sense. So so we're gonna make this a constant. So I have my C style string because I added a null character and then I dropped the force length, and I'm gonna do that as a constant. And I'm gonna call it window. And since this is a constant, to me, I'm going to do it as a capitalized. Again, Forth doesn't care about capitalization at all. So this is just for my readability. So we can use it. We have our window title now. And I also want a screen width and a screen height. So I'm going to make some more constants. 800 for the width. I'll say window. Makes more sense. Okay, so we got a window width, window height. And I'm actually going to make a constant one more thing. The first thing that we need to do in our journey to getting a window open, we need to initialize SDL2. So this is what we're going to be doing this video real quick. We're going to initialize SDL2. We're going to quit SDL2. We're going to, everything I do, I have a reverse thing to clean up after myself. So we're not necessarily quitting it right away, but we'll be creating the quit right away. We're going to create a window. We're going to destroy a window. We're going to create a render. We're going to destroy a render. We're going to clear the render. We're going to present the render, and we're going to delay our program. And that's what we're working with in this video. So when we initialize SDL, this takes some flags. So we have this, and I'm just in the actual C, the documentation for the standard SDL2 C bindings. And they're going to totally work for us, because as long as we know that the arguments need to be put on the stack first, then we call the word, and then this is what's left on the stack afterwards. That's how the fourth way is going to do it. So anyway, so these flags right here, we can put different things on, but what I'm going to use is SDL init everything. Now, these are made so that they can be ORed together with a bitwise OR operation. So you can add multiple flags together to OR them together. So since that is something that could be chained together, I'm going to pull that out into its own thing. So I'm going to make a constant that's going to hold that too. So I actually have access to this because it's part of the SDL2 bindings. So I'm going to use this, but I'm going to actually pull it out into a word. I want to call it a variable, but it's not actually a variable. It's a word. But I'm going to pull it out into a word because you might want to, in your own code, chain multiple of them together. And so I'm going to hold this in a named word, and then you'll see. It'll make sense later. Okay, so down here, I'm going to create another constant, but the reason for it is because these can be chained, and I just want them on top so you can chain them however you want together, and then have just a single word that you can use. So this SDL2 init everything. Again, this is part of the SDL2 bindings. This is basically a flag being sent into SDL2 init. And I'm putting it as a constant, and then I'm going to give it this name of SDL flags. So I'm just calling it SDL flags. So these are the flags I'm going to use to bring SDL online. So you can add more of them together and hold it in the same thing and then just use these flags. I'm going to save this file and then restart it because I'm not getting syntax highlighting yet. Huh? What? F sharp. I'm a bit confused what's happening here. I kind of want the highlighting happening, and I'm not sure why it's seeing it as F sharp. Maybe if I keep coding, it'll fix it, but I just wanted to... it's not something I've ever had an issue with in the past, but let's try this. Set file type. I'm sure later on it'll fix itself, but for this video, I want it to just work. There we go. So I just told Tree Sitter that this is a fourth file. It should already know that this is a fourth file. It's weird that again, maybe it's just I don't have enough code in it. I don't know. For some reason, it wasn't seeing it. It would just give me all white text, and that was kind of annoying. Yeah, so because that you can put multiple flags together, I just want to hold them in one thing. So this is not called, this is a constant. So, but you could OR multiple together. We won't do it in this video, but we'll talk about it in other videos. So I'm just pulling this out to hold it in this SDL flags. Okay, so I actually want some, now this is an, I don't know what to actually call this. This is a word value. So similar to constant, I have another thing that is not a variable, but I think of it in my brain as a variable. But it is it's kind of like you're defining a value in a word. So and the constants don't change, but when I use value, it is making a word that the value can be changed in it. So the one thing I want to do is capture whether I exited cleanly or poorly. So I'm going to make a word that is the exit value. And the way I do that is I'm going to put on the stack the value that I want to initially have, and then say value, just like constant, but this is something that can be changed later. And then I'm going to call this exit value. The very first thing that we need to do is initialize SDL. So I'm going to be bouncing around a little bit here because this is all boilerplate to get things set up and running, but let's define a new word, and we're going to call it initialize SDL. So to define a word, I'm using a colon, and then I'm doing initialize. Okay, and then there's this, I don't know the exact name of it, but this is a comment to tell how the stack is being manipulated. So this word it doesn't require anything from the stack when this word is called. And it's not leaving anything on the stack after the word finishes. So when we call initialize SDL, it doesn't require anything to already be on the stack. So there's nothing here on this side of the minus, and nothing is going to be left on the stack additionally after this word finishes being called. So this is right here it's not seen by fourth. It's kind of for us to visualize, but it's showing how the stack is being changed when this word calls. So imagine most of my stuff is not going to do anything to change it into the stack, but one of my words does. But it's saying it doesn't need anything on the stack, and it's not putting anything else on the stack at the end. It's not pulling anything or adding anything to the stack. Okay, and now I'm just going to go down here, and I'm going to call that SDL function. So the name of the SDL function was SDL init right here. So the fourth way to do this would be the parameters need to be on the stack first. So these are the parameters, the flags. The flags need to be on the stack first. Then we call the function, which is going to be a word for us, the word. And then this is going to be what's on the stack at the end. Okay. So we need to put first on the stack our parameter, which is the flags, which is actually SDL flags right here. So we'll go SDL, flags. Maybe I should make this underscore. That makes more sense. I don't think I'm allowed to. Yeah, okay. And then we call the word that we need to, which is SDL init. Okay, and that's the bindings for that I made for Gforth for SDL2 use the exact words. So it's going to be this exact name. And I know it's not case sensitive, but I created it the exact same way. And then we have what is being left on the stack at the end of this. Now, this is going to return a 0 if it's all successful. Returns 0 on success or a negative on failure. So what we need to know basically is this not 0? And in Forth, we can just use an if. The if clause will get run on anything that's not 0. So if it's 0, it's successful. If it's not 0, we have a problem and we need to clean up and exit. So I'm just going to use an if right here. So basically, we put this on the stack. This consumed this, and it put on the stack a number. And that number is either 0 or not 0. And this if consumes what's on that stack. If it's 0, we skip the if. But if it is not 0, we have a problem. So this is what we're going to do here. We're going to create an error message. And yeah, a standard error message. So I'm not doing a null terminated. This is not a C style string. It's just a normal Forth string. I'm going to say error initializing SDL2. I'm going to put colon and a space. We want something to happen if this actually, if this error did occur. We want to create a string, but then we want to do something with that string. So I'm going to leave that for a second. And the end of if statements have a then. I know this is very confusing, but that's Forth. Forth is if this happens, the end of the if, for some reason, there's a then word. It makes no sense to me. Maybe it's the then what happens if the if didn't occur. I'm not really sure. But anyway, what I want to do is I want to call another word called error. But we haven't created this word yet, so let's create this word. Like I said, we're going to be jumping around a little bit here. So this word, we will see that something needs to be on the stack beforehand. So I'm going to say, oh, I didn't put a semicolon here to end this word definition here. So for the error, it's going to be error. And here we do need a Forth style string. So I'm going to say C add, and I'm going to say U, and then nothing. So what this stands for is a character address and a length. And that's a Forth string. That's what this has given us. This has given us a character address and a length. So this needs to be on the stack when we call error. And this is coming off the stack, but nothing is being added in the stack in its place. So this is the error, and this is going to be the end of this word definition. So what I want to do is I actually want to output this string that I put on the stack before I called error. I want to output it to standard error, not standard out, but standard error. So the way I can do this is by actually doing a file write. I can write to a file, and I need the address of standard error, because standard error is a file. Now, I don't know if this is the same in Windows. I actually have no idea. So in Linux, standard input, standard output, and standard error are all files. Well, everything's a file in Linux. So let me show you again. Let's see, by. So if we were in here and we were going to print something, I could say, so I could make a string, I could say say error. All right, this is going to put a string on the stack, and then I could say type, and it's going to print it. Okay, so it printed error. So here it is, and here's where it printed error. I could even do a carriage return. or I could do carriage return before it. Okay, so that's really just printing it to standard output. And the way I can show you this is, let me exit it with by. Now, if I were to redirect normal standard output to dev null, which is a black hole. So if I said echo, this is just bash, or I'm in fish, but so that's just normal echo, right? And it's normal standard output. So if I tell normal standard output, which is 1, to go to dev null, it disappears. If I tell standard error, which is 2, well, I told standard error to go to dev null, but hello world is not going to standard error, it's going to standard out, right? If I told them both to go to dev null, it would be something like, what is it, 1, I always forget this one. It's 2. Yeah, that sends both of them to standard, to dev null, which is, dev null is another file that is a black hole. It just goes nowhere, doesn't do anything. So if I were to run gforth, and I were to send standard output to dev null, see what happens. That's 1. So 0 is input, 1 is output, 2 is error. So if I send 1, which is standard output, to dev null, I'm going to have to do it with, I can't do it with standard out, I have to do it with standard error. So I'm going to send standard error there, right? So if we do the same thing, if we do the if I go error, and cr type cr. So that's standard out, right? And we know standard error is going to dev null. I can't put standard out to dev null. It won't let me interact if I do that. But so let's send this to standard error instead. So what I could do is I could say I want to write this to a file, but I want that file to be standard error. So I go std error, standard error, and then I can go write file. Okay, so this is going to, write file is going to take 3 items. It's going to take a string, it's going to take a length, and it's going to take an address. Okay, ignore this carriage return. This is just, but it's going to take this string that's on the stack. It's going to take the length that's on the string address, the length, and this address to standard error, and then write it. And so we're not going to see anything because I'm sending it to null. See, we didn't see anything. Okay, now if I go by and I don't do this, now I do the same thing, we see it. So that's being sent to standard error, not standard out. Again, if I go to send standard error to there and I do that, it does nothing. It's just saying, okay, it's not printing my error message. Okay, so I know that's long-winded, sorry about that, but basically I want my errors to go to standard error, not standard out. That is the correct thing to do. So to do that, I already have the string, and I'm going to be sending it to standard error. So the string and the length are already on the stack because they're coming from right here. And then I call this word. So these things are already on the stack. So I'm putting the address of standard error on the stack. And then I'm doing a write file. Okay, so that's going to write it. But I don't want to just write that. I actually want to find out what error occurred. So we have this SDL get error. SDL get error actually returns a string to what the error occurred. It takes no parameters. We don't need to add anything to it, so nothing needs to be on the stack first. We call this word, and what we get is a C-style string. So we got that. So what I want to do is I want to get the real error. So I have my error message that I created here, but now I need to find out what really happened inside SDL. So I want that error message. So I have access to it, so I can just say SDL get error, and that's going to put on the stack a C style string, but I can't use that because that is just the character array, but there's no length involved. It's just a null terminated character array. So before we can finish that, we're going to create another word up here, and this one is going to be the C str len. We'll just call it len. And this one is going to need a character address. And this character address is just convention. This doesn't mean anything. It's just that's the way the fourth documentation has it. I could put A here, B here, Bob here. It doesn't matter. But I just know that they're using this to mean character address, and they're when they're talking about strings. So I'm just following convention. So anyway, we need character address on the stack, and what we're returning back is that same character address. So we're not consuming it. It's going to still be there. And we're also getting a length, and it's an, it's not assigned. It's not going to be negative. It's like an unsigned. So that's what this is going to do. And we already talked about it before. I'm going to put 0 on the stack. So now I have an address and a 0. And then I'm going to begin a loop. And this loop is going to duplicate the two items on the stack, which are the address and the 0, the address and the number. Think of the number 0 as the length. So far, the length is 0. And so I'm going to do toDup. toDup. And then I'm going to say plus. And that's just going to add the address and the number together, which gives me an offset. So 0 and the address gives me the address, but later on, if it's 1 in the address is going to give me the second letter of the string. So the address is the first letter of the string. 1 plus the address is going to give me the second letter. 2 plus is going to give me the third letter. So I'm going to say plus on those because I have an address and a number. Right now it's 0, but it'll be different later. And then now, since I have the address of the character I want, I'm going to fetch that character. And the way I can fetch a character is with C, the @ symbol. This is a fetch. This is a character fetch. So this is fetching 1 byte, not 64 bits or 8 bytes, but only 8 bits or 1 byte. And that's what we need to do. And then what we're doing is now we have this character on the stack. Now that the character is on the stack, we only care if this character is not 0. If this character is 0, we're ending this loop because we hit the null character. So this while here is basically saying, allowing this loop to happen until while sees 0. So if this character is not 0, while is going to consume that character to check it. And if it's 0, it's breaking out of this loop. If it's not 0, it's going to continue. And this is going to be a 1 plus. That's just going to add 1 to the whatever number we had. We started with 0, so now it's going to be a 1. And it's going to repeat. So I know this is a bit weird. This is the beginning of the loop. We have an address and we have a number. We duplicate those two. We add the address and number together. Remember, we have 2 addresses and 2 numbers, an address number and an address number. We're going to add the top address number together to get an address. We're going to pull the character out of that. So now that address is gone and now the character is there. The while is going to check that to see if it's 0. And now that's gone. And now we still on the stack, we have our original address and number. And if we haven't broken out of the loop, we're adding 1 to that number. And then the repeat goes back. And it just keeps doing it until finally one of the characters comes out as 0. And then the while breaks out. We don't add anymore. And what we end up with is our original address and the length of our string. Okay? So that is going to be that word. And we're going to use that to turn our C string into a 4th string. C string lang, and now we are doing the exact same thing that we did before, where we're doing the std error and then the write file. Okay, so basically we took the message I made and we wrote it to standard error, and then we took the message from C internally, whatever error occurred, and we're turning that into a 4 style string, and then we're sending that to standard error. But I also want a carriage return on this, on the standard error. So what I'm going to do is I'm going to make another string, and I'm going to just put the I'm going to do an escape sequence on a return, on a new line character. So this is just going to contain the new line character. That's in, and I'm going to do the exact same thing. Okay, so this is almost done. This is basically formulating the error message to standard error, but now I want to shut this program down. And also, for one, if an error occurred, see I have this 0 value, the exit value. Well, in most programs, when you exit with a 0, that means you exited successfully. 0 means it exited good. If you exit with a number, like say 1, something bad happened. So if I was in C or C++ and I wanted to say that the program exited badly, I would return a 1. So what we're going to do here is we're going to change this exit value from 0 to 1. So since this is a word, there's a value of 0 in the word, we're going to take 1 and we're going to put it to this exit value. That's how we change the value of exit value. We have a 1 on the stack and we use this 2, and that stores that value or sets the value of exit value to this 1. Okay, and then I want to actually clean up the game. So game cleanup. Now here's another problem. We haven't created game cleanup yet. So let's create that. So I'm going to create it above all of this here. The reason why I'm putting it above, because it already needs to be known. So when I call error, this already needs to be known because I'm calling it here. This word needs to be in the dictionary. Okay? This word also needs to be in the dictionary. So it needs to be above here at least, but logically I'm just putting it even further above. So game cleanup. And this is taking nothing off the stack and putting nothing on the stack. And the only thing I want to do with this is the thing that when we're shutting down. So right here, we are starting up SDL with SDL init, and that takes a parameter and it returns a value, which is 0 or -1. The way we shut down SDL is with SDL quit. And this takes nothing and returns nothing. So it's just SDL quit. So we're going to do that. That's going to be our cleanup so far. So right here, we're going to say SDL quit. And this again, this is the actual function or word call. This is not the enum. The enum is going to have an underscore enum at the end of it. That was one of those word collisions that we had that I talked about earlier in the video. So this, and now we actually need to exit the fourth program. And the way that you exit fourth programs is by saying bye. But we don't want to do this because if I just say bye, it's going to just exit with a 0. What I really want to do is exit with the exit code that I have stored in exit value. So if I put that on the stack, exit value, and then say bye in parentheses, this now will actually exit the fourth program, but it'll exit with this value here that I had on the stack. Okay? So I'm going to end off the definition of that word. So this is how we're closing the program down. This is how we're converting C strings. We're just adding the length so we can use them as fourth strings. This is our error. I know it's a whole lot of boilerplate we got going on. So now down here, we can initialize SDL. If there's an error, we're shutting down. I know we're only initializing, so why are we shutting down? But we will be initializing more things later. So at any point, we can shut down. So we're initializing. If an error occurs, we have this whole thing where we're making an error message. We're putting that on standard error. We're getting the real error message. We're putting that on standard error. We're giving it a new line. And then we're changing our exit value, and then we're cleaning up. So we're not actually making a window or anything yet, but that is a whole lot. And we haven't called anything yet either. So since we haven't called anything, I'm just going to save this. So we can't really run it. I mean, we can run it, but it doesn't do anything. So I'm not even sure if it'll actually run. It just put me in interpreted mode because we're not actually, we basically are defining words here. We're requiring SDL, and we're creating constants, which are words, and we have this other value here, which is also word. We're defining these words, but we're not actually calling anything yet because we're not there yet. So now that we have SDL2 up and running, we need to create a window. Now I did have this open. I didn't get it around to it because it's very white screen, very bright. But this does talk about some of the memory access, and this is the normal way that you store, but this would be a 64-bit store. And this is a character, but down here, where is it? There is SL right here. This is the 32-bit signed extended 32-bit right here, and this is the stored bottom 32 bits. This is the to store, and this is the fetch. So yeah, just touch on those real quick. So what we need to do is create window. So to create a window, we have a string, we have an X, a Y, a width, a height. Now, I already talked about this a little bit before, but the X and the Y is where you want your window to be on your screen. And I just want it to be centered. I don't want to try to figure out, I could put it at 0, 0, and it would be in the top left-hand corner, but I just want to center it. So these are internal macros that figure it out for you. They do some math on what your actual window size is and what the screen is, and then they center it for you. So I'm going to use those for both X and Y. Width and height, we already have constant set up for those, so I'm going to do that. And the flags, we don't need any flags. I could do window shown. I think it's what I've done in other videos. Where is it? Oh, window shown is ignored. Yeah, so I think I've used window shown before. We can just put 0. So I'm just going to put 0 as the flags. That's what I have in my notes. So basically, we're putting all these things right here. Item on the stack, stack, stack. Put all these items on the stack, and then let's call this word. And what we're returning, what we're getting back on the stack when it's done, is this pointer to an SDL window. Okay? So yeah, let's do that. So I'm gonna do this in SDL initialize. So it's gonna be here. And we remember we need to put all those parameters that we need on the stack. So we already have the string that we need. It's called window title. Window title right up here. We already have that. So let's just use that. So I'm just putting it on the stack. And then the next item that we need on the stack is the SDL window pause centered. I think it's written like that. And we need that twice. That's for the X and the Y. So SDL window pause centered. And then for the width, it's window width. And then the height is window height. And then we can just add a 0 for the flag, for the last flag, so we're not using it. So I believe that's everything we need there. So I'm just putting all these things on the stack. I'm just going to wrap this around because it's getting too long. And now we're going to call the word that is the SDL create window. It's going to consume all those things off this stack. SDL create window. And what it's going to leave on the stack is this pointer to an SDL window, right? And how do we know if it failed? Well, it's going to return that window pointer for null. If it fails, it's not going to give us a pointer, it's going to give us a null. So a pointer is just an address location. But if it fails, if this word or function fails, it actually gives us null, which is nothing, 0. I mean, it doesn't give us nothing, it gives us a 0 on the stack or an address on the stack. So I want to hold this, and I'm going to hold it in a word here that, you know, one of those value words. I don't know what you call it. I want to call it a variable, but I know it's not called a variable. I don't want to use the wrong word. So what I'm going to do here is I'm going to create a word that's holding null, and then we're going to set it to whatever we get. So initially it's holding null. And I'm just going to call it window, okay? Not with a capital W, just a normal W, okay? So we have this, again, it's not a variable that we could use a variable, but it would look slightly different. But instead I'm holding it in this, it's like a compiled word or something. It's a value in a word. But the value right now is null, which is actually 0. And so right here, we're going to get an address back, or we're going to get 0 or an address. Okay, so what I'm going to do is I'm going to set that whatever the thing on the stack that we get back is, I'm going to set it to this window. And the way that we do that is with the 2. Notes, there we go. So we're going to say 2 window. Okay, so now we don't know if it failed or not though, right? Because window could be a real address, or it could be a 0. And we need to know which one it is. So we can throw window back on the stack now. That whatever the value of window is, 0 or an address, is going to be on the stack. And we can compare it to 0. If it's 0, if I just put an if here, and it's a 0, the if doesn't get hit. I want the if to trigger if it is 0, not if it's something. If it's nothing, it's a problem. If it's something, it's an address. So I'm going to say 0 equals. Okay, so imagine if this is 0 and this 0 equals is going to say that's true, and this if is going to be triggered because we don't want 0. So if this happens, we're going to do the standard thing that we've already set up to clean up. We're going to do the S, and we're going to say error creating window, and I'm going to put a colon in space, and then I'm going to say error. And that error is going to take care of printing the error messages and cleaning up and shutting down. And we're going to put the then here. Okay, so this is putting all the parameters we need on the stack. This is consuming them, and then it returned on the stack something. We're holding that something in window. We're putting window back on. Right now, there's nothing on the stack, so we're putting window back on the stack to compare it, and use the if. If it happens to be 0, we got a problem. Okay, so now that we have this window thing, we need to destroy the window. So in our cleanup, and as I build this up, I'm going to be destroying it backwards. So here, before SDL gets shut down, I need to destroy anything that was created first. So I'm going to say window, and put that on the stack, and the way you destroy a window is with SDL's destroy window. And it takes in one parameter, which is a pointer to a window, and it returns nothing. So we need this on the stack, and then we call the word. So it's SDL destroy window right here. So I put window on the stack, and then we call this, oops, shouldn't have done that. There we go. And this is not returning anything on the stack, and neither is SDL quit. And I am separating these because what I'm doing here is I'm going to be destroying all the pointers. These are all heap allocated by SDL2, and so we need to destroy them. We need to unallocate them, you know. And so I'm doing that the correct way, and I'm doing it in reverse order. So whatever is the last one that I created is the first one that I'm going to remove. So this is now my shutdown sequence. Whether it's good or bad, it's going to shut down that way. And so that is creating a window. But now that we have the window, we need to create a render. So we have this down now. Window created is done. Render created is done. Window destroy is done. So SDL create render is very similar. So this one, we have 3 parameters. We have the pointer to the window. We already got that. We have an index. And the index down here says the index of the render driver to initialize, -1 to initialize the first one supporting the requested flags. So we're going to use a -1 here. So it's going to be our pointer to our window, a -1, and then we have flags. So if we use no flags, it gives us priority to SDL render accelerated. So sometimes I use accelerated, but we can just use 0 as in no flags or null. It doesn't matter. 0 is fine. We can use 0, and this is the one that it will try to use first. If it doesn't work, it'll fall back to software. So, whoops. So what we're going to do here is I go back to the thing. So what we're going to do here is we're going to use a window. we're going to use -1 for it to use the first available, and then we're going to set this to 0. And this is, so these need to be on the stack, then we call this word, and then this is what the address of the render is, what's left on the stack afterwards. And we'll do the exact same thing that we did with the window. So I'm going to go below this here, and we need the window on the stack. We need -1 on the stack, and we need a 0. And then we do SDL create render, and we're going to do that to render. I know we haven't created it yet, but that's what it's going to be. So up here, just like we did before, I'm going to put null value render. Okay, so this is going to hold the pointer to our render. This one's holding the pointer to our window. So we're going to do the exact same thing that we did here. I'm just going to copy this. But we're not checking the window, we're checking the render this time. Okay, and same thing, if it's a 0, it's a problem. So our message can be error creating render. Okay, and the error, that does the whole sequence of creating the error message and shutting down for us. So that is all good. So now we have created in our code so far, we haven't actually been able to launch it yet, but I know there's a lot of boilerplate involved. But we have created a window. Well, we initialized SDL, we created a window, and we created a render. And so our shutdown, we are destroying our window and quitting SDL quit. We're quitting SDL. So what we actually need to do is destroy the render now first. So I'm going to say render SDL. Well, it's actually right here. I didn't show it to you, but SDL destroy render. It just takes in a parameter as a render, so that needs to be on the stack first, and it's giving us nothing back, and it's called SDL destroy render. So that will be here. And the other thing that I forgot to do a moment ago with window is I don't want a dangling pointer. I don't want this renderer, even after I destroy it, that the memory has been reallocated, to the system or whatever, or to, it's no longer being used for the render, right? That's been destroyed. However, the pointer being held in this word right here is still there. So if I try to use it again, we're going to have problems. This is a dangling pointer, or use after free, or however you want to say it. So I'm going to set this to null again. So I'm going to do null to render. Okay, I'm going to do the same thing to the window. I should have done that. I know we're cleaning up and we're shutting down code, but I want to use best practice. I don't think we should have dangling pointers hanging around. If you do it everywhere in your code, you're never going to have, segmentation faults because of that. So, so now we are destroying the render and all that. That's great. So we should be able to make a window almost now. We got almost everything in place. We're getting really close. What we need is a game loop. I'm going to call it game loop, even though it's not looping in this video specifically. Sorry, I didn't want to do that. I just wanted to get rid of the one line. But I'm going to call it game loop. So we're going to define another word called game loop. It will be the loop in the future. And it's going to take nothing from the stack and return nothing. And what we want to do is we want to create a window, right? I'll show you what it looks like if we don't. I'm in my game loop right now. I'm just going to put a delay. I'm going to skip a couple things because I want to show you when it's not done correctly. Okay, so we have this thing where we're going to clear a render, we're going to present a render, we're going to delay the program, and then that's it, right? So whatever we do, we're not going to see it. It's going to happen so fast. So what we need to do is we need to delay the program for a couple seconds so we can see it. So I'm going to use this delay first. This delay, and it takes milliseconds in. If we want it to delay for, say, 5 seconds, we're going to put 5,000 in here. So 5,000 on the stack, call this word, returns nothing. That sounds good. So 5,000 SDL delay. And then what I'm going to do is I want the program to exit, but I want it to exit cleanly. I want it to clean up after itself. And we've already made this. We've already made this to clean up after itself. So we're going to call that. So right down here, I'm going to say game cleanup. That's the end of this word. And we still haven't called anything yet. I'm going to make one more word. And this one is the game play. This is basically going to bring everything online and then call the game loop. So here we go. We got game play. It'll make more sense in the future. Basically, this is going to be handling only the game loop. This is going to handle bringing everything online and then calling the game loop. So this, again, is taking nothing off the stack and returning nothing. And what we need to do is we need to call this initialize SDL. Remember, we've made this word that brings SDL online, and it brings the it creates the window and it creates the render. We need to call that. So I'm going to call it here. Initialize SDL, and then I'm going to call the game loop. And then that will be the end of that. Okay, now we can just call play game. Gameplay, sorry. Oh, I called it play game in my notes. Yeah, just say play game. Okay, so basically I'm calling, this is the one thing I'm finally calling it. So I'm calling this word. It's going to go up here, and this is going to call this word, which is going to go up here. It's going to run through these unless it hits an error. If it hits an error, then it's calling the error, it's changing the exit value, and it's calling the game cleanup, which is going to deallocate and shut down and exit with the bad code. But if not, it's going to keep going through. When it gets done with that, it's going to move on to game loop, which is going to go in here, and it's going to delay the program for 5 seconds, and then it's going to clean up. And then that's the end of it. So this we should actually be able to run. And I want to tell you that the window is not, if it does show a window, it's not going to look correct. And then we're going to fix it. So it's meant to not look correct right now. Okay, there it is. And I'm going to move it around and see how it's not correct. We've created a window, but we don't have a render. We don't have like our canvas that we've painted to. Yeah, so what we need to do is we need to do that. We need to show our canvas that we're painting to, which is called the renderer. So that was the bit that I skipped. So we can clear the render, so we can blank out our render, but even if we do that, we still will not see it. We actually, what it's done is it's a back buffer. So we have this render that we're clearing, but we still don't see it until we present it. So what this is meant to do is this is meant to be a back buffer where you can paint all your items on this thing, and even if it took a long time, even if it took 20 seconds to paint all your items on there, the user would not, or the person playing the game would not see any of these items being painted at all. But then when you hit present, it's going to show it to you immediately. So what's going to happen is whatever the last thing that was presented is going to be shown to you until the next thing gets presented. So you're going to be looking at one image, one painting, while the other painting in the background is being painted too. When that is finished, it's going to swap the buffers, and you're going to just instantly see that finished painting. So this is a double buffering. This is a way, so even though we're clearing a render, we still, if I were to show you the code again, it would still look garbled, it would look messed up. But when I present the render, it's going to look fine. And all our drawing is going to happen between these two. We're going to clear a render, do all our drawing, and then present a render. Okay, so basically these two are very simple. They both just take the render. So the render needs to be on the stack, and then we call render clear or render present. And it's written a bit funny. It's not renderer, it's render. And I get that that's just the way that SDL wrote it, but yeah, let's just throw these two on there so we can see our window. So the first one is going to be the render clear. we need the render we need that on the stack first, and then we have, I'll say, render clear, and then render present. Okay, and render clear actually returns an error or not, and we're not checking any errors in a game loop. We're going to check errors on things that are loading, but not things that are happening very fast in the game loop, which is later on what will be happening. This will be very fast. And we don't care if it didn't clear for 1 frame. So we're not checking this, but it is still on the stack, so we need to get rid of it, or the stack will just keep growing. So I'm going to drop it. And if we look at the render clear, where is it? Render clear, it returns an int, returns 0 on success or negative. We don't care if it was successful or not for this one, so we just need to drop that. But the render present doesn't return anything. So on this one, we do need to drop. On this next one, on the present, we don't need to drop. And then we're delaying, and then we're cleaning up. So now we should see a black window, and it should stay open for 5 seconds, and then it's going to close. Okay, that's perfect. And here's the title up here. It's called Open Window. And if I open it again, I can move it around, and and it's not messed up. It's fine. It's black because we're not drawing anything to it yet, but that's fine. That's what it's supposed to look like. Now, do understand that if you try to close this, if you try to press on Mac, I think it's a red dot, or in Windows, it's an X or something, or if you used a key combination to close it, it will not close. And it will still close after 5 seconds, but it will not close when you tell it to close. And when your operating system may tell you that the program is not responding. That's because it's not responding. It's not responding to your close request. What it's going to do is it's going to stay open for 5 seconds and then close no matter what. But when you ask it to close, it's just going to ignore you. It's not going to, but it will still close at the end of 5 seconds. So that's fine. That's because we're not checking events, which are close events. We're not checking them, and we're not dealing with them. And so your thing will say maybe for a second or two that it's not responding before it closes. And we will deal with that in the next video. This video was just all about boilerplate, getting it up and running. Everything's in place here. We got all this stuff going on. We've dealt with errors and cleaning up, and everything's kind of ready for us to go for the next video. So I know that's a very long-winded one, and this is not a 4th tutorial, but I hope that was educational or entertaining. Again, these SDL2 bindings here, I made these, so I couldn't find them anywhere, and I hope they work for you. I'm on a 64-bit system. If they don't work, give me contact on the GitHub page or under the video, and I'll try to help if I can. But yeah, know that these are not like official bindings. These are literally bindings that I worked on for a while and finally got working. I wasn't able to find anybody else on YouTube or anything that has anything close. They just show a thing that can open a screen. This thing can do everything. You should be able to do anything that SDL2 does. It's got it all. And hopefully it works. Let's run it one more time. Not over there. Okay, and notice that it's not slow. It's only the very first time that you compile that's going to be slow. And I can't close it. It only closes after 5 seconds. So that is how to open a window in G4 and SDL2. Okay, so thanks for watching, and I'll catch you in the next one. Bye.